Our last example is graphing a piecewise function with a graphing calculator. You probably haven't done this before, so I'm going to walk you through it. In order to save a little bit of time, I do have the red function typed in, so sine of x when x is less than 0. So notice I used that fraction that we saw in the last video. The function goes in the numerator and the constraints go in the denominator. I'll show you how to get the inequality symbols in when we put in the second one. The second function is a bit more complex. Notice the x is in between two values. Your calculator doesn't understand this sandwiching the x value, so we do have to split that up, and I will show you how to do that. And I have the third function in, that cosine of x, where x is greater than pi. So together, let's type in this second one. Again, we need to start with the fraction, so alpha y equals, and that first option is just strictly numerator over denominator. Type in the function in the numerator, 1 minus cosine of x, and then we're going to type in the constraints in the denominator. So we need to type in two constraints, and we always have to start with x. So we're not going to type in 0 is less than or equal to x. We're going to type x is greater than or equal to 0. So using that same x button, the inequalities are under this option called test. Notice it's in blue, so we hit second math to get into the test, and here's all of our inequalities. X is bigger than or equal to 0, so we're going to hit number 4 and put in 0. All right, but that's not the only place where this function is true. So now we need the word and. X is greater than or equal to 0, and x is less than or equal to pi. Go back into test, and this time when we go over to logic, here's where we have our connectors. So we want and then we type in that x, back to test. This time we want the less than or equal to, so I'm going to hit 6, and pi. Go ahead and type that second pi, and that'll pop up as an exact value. Do not use 3.14, use the pi button. So that's also how I got my first and third equations in there. So if you want to pause the video to get caught up to me, and then we're going to take a look at the graph. My graph is still set from that first example. So the first thing that you always want to do is make sure you have an appropriate window. So we're looking at values for sure from 0 to pi, but then also a little bit smaller and a little bit bigger. So I'm going to go from negative pi, and you can type pi right into your window, so second pi. It automatically changes it to a decimal for you, which is fine. And then I'm going to go to 2 pi. For my x scale, I decided I want to see marks at every pi over 2. Now my y value, I know trig functions bounce between -1 and 1, so for my sine and cosine function, that's just fine. But for that 1 minus cosine function, I'm going to have 1 minus -1, which is 2, and 1 minus 1, which is 0. So that's going to bounce between 0 and 2. So I'm going to go, just to make sure I can see everything, from -2 to 3, and then hit my graph. Notice the pieces of our function only show up for the domain that we told it to. So this blue one is our sine function. Of course, sine continues forever, but we told it to stop at 0. This middle piece is that 1 minus cosine, which also would go forever, but we told it to start at 0 and stop at pi. And then this black one is our cosine function. We told it to start at pi, and then it's continuing forever. The question for this example was, look at the graph to determine where the limit does not exist. So let's see what's happening at the breaks in our functions. We know sine is continuous function, so is 1 minus cosine, so is cosine. So as we're approaching those breaks here, the limit as x approaches 0 from the left and the limit as x approaches 0 from the right are both converging on the same y value. So that limit does exist. We see an obvious gap or a jump right here in the graph. as we're approaching pi from the left and as we're approaching pi from the right, we get two different values. So therefore, the limit as x approaches pi fails to exist. So we can say the limit, I apologize for my handwriting, especially with a stylus, as x approaches pi for this function does not exist. You do have another lesson, 1.3. I promise it is far simpler than 1.2. So what I actually want you to do right now is do not watch the 1.3 video. Try your 1.2 assignment. You really got to get practice with this first intro into limits before we start 1.3.